From my experiences, I really feel that Mathematica is a tool that schools should embrace early. It's not a question of should we embrace it, but I think the earlier we get started on it, the better. Being able to see things in 3D instantly with color and shading, and now I can grab them and swirl them around and look from whatever viewpoint has made a huge difference. So we can understand concepts with reasonably simple examples, but then using the capabilities of Mathematica, we can immediately work with harder examples, more interesting problems that if we were just pencil and paper by hand, we couldn't even tackle them because we just couldn't get through the problem in 60 minutes or whatever time they had. So no, I'm not going back.
What I find most intriguing is when a student finds something that resonates with them and they play it through the scroll bar and they interact with it. And there's this childish enthusiasm that comes out. And you'll hear them kind of giggling and just saying, this is so cool, because they actually envisioned something. It may not be sophisticated. It could be expanding x plus 1 to the nth power, it doesn't matter. But they brought it to life and they were able to see things change. And then that leads them to exploring other areas.
It's really hard, for example, to draw pictures of 3D surfaces that are, as easy to see and make the connections between the two-dimensional slices as Mathematica can. Hard to solve these higher degree equations by hand, sometimes impossible, so it's really nice that Mathematica can do that and again make that jump from the theory to real world answers and help them work some examples to see how some of these things actually solve. They just get really excited about it. I mean, just, wow, look what it did. Look at that really cool graph I just made. And spin around, oh, that's really neat. Oh, how can I do this at home? Anything that gets them that involved and that excited, makes them really want to go and work some more, is just got to be a good thing.
You can communicate ideas so clearly, and in many cases it's the motion and the dynamic interactivity that a manipulate allows that allows the essence of an idea to be clearly communicated. I mean, you never hear so many ahas as when you can move these things and watch how something happens. Say, I see it. I see not just a static image, but I see the underlying concept or idea. In mathematics in particular, but I think in many disciplines.
One of the benefits of Mathematica is that its applications are so broad that I use it in all my courses. So I don't have to learn a new piece of software if I were to teach a statistics class or a differential equations class. And I see, okay, what can I do with Mathematica and differential equations? And I'll pick up a textbook and use Mathematica to do many of the things that the textbook does. And pretty soon I'll be going much deeper than that textbook went. So it just gives me a tremendous amount of power.
The really cool thing about Mathematica is that the students are able to work in a self-contained environment. They can work all inside a notebook and do everything, their calculations, their graphics, their writing and everything. It's very important that there's the flexibility for them to learn at their own rate and for them to have the power to take the time on the lessons. We are all about using mathematics as a process. So we're trying to see what their process of learning is and teach them that math is the process. It's not about answers. And I think Mathematica helps us do that.